Okay, so the last talk of the session will be the Empirics track exemplary paper, choice architecture, privacy, valuations, and selection bias. And Avner Schlein will give the talk.
Thank you for having me. Very happy to be here. Don't know how I got to this stage right now, but you need luck in life, I guess. Okay, so this is a joint project with Tesary, who his picture is here, but she couldn't be here, unfortunately. So let's start. Many companies' business is data. Many companies' business relies on data. If you think of Google, Facebook, etc., what they sell, what their product is the huge vast of personal data they have on consumers that they then use to make money somehow. And these data come from consumers who willfully or unwillfully share it with them. Okay? And one issue with privacy valuations of people valuing their own private data is that it's pretty hard to do. And that might lead us to think that the times at which consumers share or do not share their data is kind of noisy. And the company might not know if the consumers will share the data or not. So companies naturally would like to influence the sharing decisions of consumers, and they will take different measures to do that, right? So you want to change behavior in a way such that more consumers will share their data, okay? And one natural way to do it is via choice architecture, also known as frames in the decision theory literature, or nudges in the or a subset of that. And I might use those terms interchangeably. So what does choice architecture looks right now in data sharing? You often see something like that, where you go onto a website and then it asks you for your cookies preferences. And what you will notice is that often you'll see everything is pre-checked. The default is for you to share everything, okay? And the company that offers that service, Cookie Pro, they are a third-party provider to different websites. They will say, well, we're going to offer you concentric optimization that will maximize opt-ins. And that is kind of the common practice of what you're trying to do, is you're trying to get as many people to share their data with you. That's the idea. You're going to find the choice environment that will maximize the volume of data that you get. Now, today, I want us to think about the heterogeneity of the effects of the choice environment. So we might believe that there are different types of people whose data we want, and they differ in their baseline value for data, and we have different choice environments, and those different choice architectures influence them differently, potentially. Some people are more susceptible to the choice environment, some are less. And thinking about the joint distribution of those two factors might matter, because once you start thinking about it, you quickly can see that there might be a trade-off here. That when I maximize data, I might have a different composition of people who share their data with me, rather than if I choose a different choice environment. Let me, okay. I'll go to the research question first. So we're going to start with a couple of baseline questions. Other people have studied those questions, and that's kind of a warm-up for the main thing in the paper. So first, do people even have an idea of what's the value of their data? My prior going into this project was no, that we will find just pure noise. But I'll show you some evidence that they actually do know what their data is worth to some degree. On the other hand, they are highly affected by the way we elicit values. Okay, so they are very susceptible to the choice architecture. And we can change market shares of who shares data at different prices by about 50%, okay, just by phrasing the way we ask the question differently. Those two questions would then lead us to the main point, of this joint distribution. So what does the heterogeneous susceptibility to frames imply for data collection? What does that imply for data quality, which we think of as the composition of types who decide to share their data or willing to share their data? And then at the end, I will touch briefly on what does that mean if we think about it as a tool that companies have. What can they do? How they can use choice architecture better to have higher quality data? I just want to emphasize that what I'm not asking here is what is the value of data. I think this is kind of a moot question because it's highly context dependent, and I don't think consumers know their true value of data, so how could we? Okay, so this is kind of a proof of concept of a point. I'm not going to give you a number of this is the value of data. We will have numbers, but don't trust them as it. It's also what I'm not asking what is the effect of any particular choice environment. You will see we will elicit valuations for data, but it's not what companies will do. Okay, so again, this is a proof of concept, not a study of the real market for data. Okay, so to illustrate the point of what I'm doing, here's there's an Econ 101 figure. So here you have the share or the number of consumers who share data. This is price. The red downward sloping curve is the demand from the company's side, the company who buys data. And we have two supply curves. And you can think of what does choice architecture does. If we start with one supply curve, we might find a better way to get people to share, and that will shift the supply to the right. And then what will happen in the standard market, we're just going to get more people sharing at a lower price. Okay? But now let's think about the type heterogeneity. So let's say we have blue types and yellow types. Here we tag them as income, but that doesn't matter. Okay? And let's also assume that the yellow types are more affected by this different choice architecture. So when we shift to the right, we are not shifting the curve uniformly. We're affecting the yellow types more than the blue types. And what that will cause is that in this new regime, if we start with a third blue types, now we have only 5% blue types. To the extent that we care about the composition of the data, then that might matter. Okay, so the trade-off arises. But does that happen? We'll see shortly. So first, I want to say that companies might care about it. So here's, if you have biased data, that might feed into your algorithms and lead to poor decisions. Here's one example from a few years ago. Amazon trained a tool for helping it with hiring decisions. They didn't realize that all their employees are male. The algorithm learned to penalize any mention of the word women in CV, such as women's chess club, or if you went to a mostly female college. And then they just exacerbated the bias in their hiring decisions. Okay, so biased data can be quite detrimental. And what we want to do then is to learn about what happens in practice. Is there a trade-off or is there not? Maybe the optimal thing to do is to always just get as most data as you can. So what we did is we recruited about 5,000 Facebook users via Facebook ad and from Prolific. And we elicited their willingness to share, willingness to accept, to sell us their 5 different types of Facebook data. Okay, their history of posts, real data, posts, likes, their list of friends and followers, their About Me page. The 5th one is not Facebook data. This is kind of the survey questions we asked them about their income, age, education, browsing behavior, etc. And what we're asking is for their permission, either to send us their real Facebook data and their permissions for us to share it with advertisers. Had we changed the usage of the data or the way we say that, that might influence values. And that's, again, why I'm not emphasizing the numbers per se that we're getting here. Okay? Then between participants, what we're varying is the choice architecture. So we are going to elicit their willingness to accept in an incentive-compatible way, in a standard model where the frames don't matter. Everyone should report the same values, but they will matter. So that's the point here. And then that's the idea. So how do we elicit the value? We are asking for each data type. We first ask, let's say, posts. If we tell everyone that the computer has already chosen a price between $0 and $95 with our uniform distribution at the beginning when they just consented, which is true. And then one of their questions might be randomized to be implemented. And if they agree to share at that price, they will send us their data. We will send them the payment. Okay? So if the computer chose $50, will you share your posts? Yes, no. If it's 60, yes, no, et cetera. Just a standard multiple price list. And here we have someone who said no to 80 and yes to 90 and 100. On the second screen, we get their more precise number, perhaps. And we allow people to be inconsistent and go back and forth, and just as a check that people actually understand what's going on. Okay? And people are pretty surprisingly consistent. So what does our experimental manipulation looks like? That's what you've seen before. We changed the price range between participants. Okay, so some people see 50 to 100 on the first screen. Others see 0 to 50. Okay, that influences their decisions. And we also changed the default. So here, in the all yes condition, all the yeses are pre-checked. So you agree to share at the lowest price on this price range. We can change it to active choice where nothing is pre-checked, or to an all no, right? An opt-in, opt-out design. Pretty standard. OK, let's look at some results. So here's, for the first question, do people even have an idea what the data's value is? One way to look at it is, another thing we varied between participants is for their posts and likes, we varied the duration of time of data that we were asking to buy. So some people, we asked for the data since they joined Facebook, others the data from the last year, and others just from the last month. Now this is purely between participants, so they can't anchor their choices on what they chose in the previous round, et cetera. And what you see here is it's the same supply curves that I illustrated before, in a sense. And you see everything shifts in the direction that you expect. So for any given price, more people are willing to share data just from the last month than from the last year, than since they joined Facebook, which is on average about 5 years. Okay? So without being able to compare, people do have some value, some vague idea. On the other hand, they are also susceptible to the manipulation we had here with the choice architecture. Okay, so these are the different default conditions, and you see pretty much the same picture. Now, what we're comparing here is if the all yeses are pre-checked, more people will share at any given price than if the all no and the active is in between. Okay? The effects of the price range are much stronger. So here, we have a bigger effect. So it depends. I'm not going to touch on how we deal with the extreme values right now, but basically we get about 15% impact on the average willingness to accept with the default, and about 50% effect on the market shares, or the average willingness to accept with the price ranges. Okay, and you see bunching at 50 here because 50 is shared between the two different price ranges, and people tend to bunch at the edges. Okay, and that brings me to the third point. So we want to think about the joint effects. What we're going to do is two things. One is we're going to use causal forests to just based on the survey questions on the demographics and browsing behavior, we're going to predict the reported value for each person from each treatment. And then we're going to look at how that correlates with their different types. And we can say, what does the average value look like between types? What does the effects of frames look like for each type? And what you see here is in the top panel, that's the different covariates we have and their effect on the average value, so averaging across the different 6 treatments, the average predicted value. And here on the bottom is the susceptibility to frames, which we define as the max difference, the effect on the max difference between the highest willingness to accept inducing frame and the minimal willingness to accept inducing frame. Okay? And some covariates have this negative correlation where if you're higher income, more educated, older, you have a higher baseline value and you are less susceptible to the frame effects. So perhaps you're more certain about the value. We don't know what causes the frames to be less effective, but that's the finding. And once you have this negative correlation, that may arise the same pattern that I illustrated with the blue and yellow types, where the high types are less susceptible to frames than the low types. And we can actually now, we can do it with the forest predictions. We do it in the paper here. I'm just showing you in the data, simple means. You can ask for each price here for $25. If I were to offer $25, how many people will share? Now that's on the vertical axis. And what will be the bias in any known covariate, okay, compared to the full sample? So if I offer $25 and I'm trying to find the choice environment that maximizes data sharing, that will be the low price range, all yeses pre-checked. I will get close to 50% of participants sharing, but the average income in that sample will be $4,000. Here it's lower, it's everything in absolute value than the average sample. So lower income people will share. I can choose a different choice environment with the goal of minimizing the bias. I will have fewer people sharing, but I will be closer to the average income in the full population. Okay? And this is the trade-off. I can change the price, and I can move along those curves. And you can see here, going in jumps of $5 from 25 to 90, I will have different frames that minimize the bias. It's always the low price range, OVS, that maximizes volume. But this bias exists. And the steeper the slope here, it means that I'm gaining less on bias reduction and losing more on volume. The flatter it is, the opposite. We can look at just taking a standardized measure of the different covariates and just averaging them as a simple example. Here, the trade-off is weaker, so you can see that you don't lose much in terms of volume, but you can gain a lot in terms of representativeness of those baseline covariates. Okay, so I'm out of time. Look for the paper in the future. It's still a work in progress about how to personalize choice frames in order to use it as a tool to mitigate the bias when you're collecting data in a dynamic fashion. It's going to be cool. Thank you so much.
Hi, I was curious if you're worried at all about selection effects, given that your experiment is kind of asking people to provide data.
Selection of what?
Like people who select into your doing your experiment in the first place.
So again, this is not a representative sample, right? We have a sample of people on Facebook who click on Facebook ads. The ads call for, are you willing to participate in an academic study and get paid? Yes, this is a selected sample. Again, the point is not saying this is the distribution of how many people will share their data at each price. The point is this trade-off exists in real-world data. It's incentivized, it's incentive compatible. People do send us their data when we offer to pay them. So yes, it is selected, but I don't think it matters that much.
I have a question, and that is, do you think there's a way that third party, like maybe the browser, can help different parties who are monitoring their users with cookies understand the selection effects that they're actually receiving when different subsets of people enable different cookies?
Yeah, I think to the extent that they track what's going on and who consents when, yes, they can definitely provide some statistics to, if I got your question right, yeah.
All right, awesome. Thanks
So
again.
much.